Yeah, fine. So today we are going to start Kubernetes. So anyone having any questions on Docker and Docker level questions ఉంటే అడగండి. So మనం 2 days networking discusses Docker networking, right? We worked on Docker networking for 2 days, yesterday, day before, right? And also we discussed about Docker file, Docker containers, right? Docker images, different concepts. Fine. Yeah, now let's get started. Kubernetes. What is Kubernetes? Why Kubernetes? What are the importance of Kubernetes? Okay, so look at here, we will go. So agenda here is why Kubernetes, what is Kubernetes, features of Kubernetes, Kubernetes versus Docker, Kubernetes architecture, Kubernetes use cases, hands-on Kubernetes. These are all very, very important. Okay, now let's move on. Why Kubernetes? Look at here. Better infrastructure. So when we use Kubernetes, we can have a better infrastructure, right? So better way through, we can manage the resources in better way. We can manage the resources in better way, right? Now look at here. Better management through modularity. Better management through modularity, right? We can manage the resources in better way, right? Look at your containers, pods, different resources you can manage in better modularity, right? Next one, look at here. So deploying and updating software at scale. So we have auto scaling is available in Kubernetes. Auto scaling, we already discussed in AWS, right? What is auto scaling at anyone? Auto scaling, we discussed in AWS. Yeah, we can scale up the resources whenever needed, right? We can increase the servers, we can increase the storages, we can increase the network whenever needed. Yeah. Next one, laying the foundation for cloud native apps. Laying the foundation for cloud native apps. Okay. So here, Kubernetes not only, yeah. So Kubernetes we can integrate with not only AWS, right? We can integrate with Azure, we can integrate with GCP. So we can integrate with any cloud platform. So Kubernetes not only for AWS, we can integrate with any cloud platform, right? Now look at it. What is Kubernetes? Kubernetes it is a container management system developed by Google. Kubernetes is the container management system developed by Google. So Kubernetes is an open source portable system for automatic container deployment and management. Kubernetes eliminates many of the manual processes involved in deploying and scaling containerized applications. Containerized applications, right? So it is a open source portable system, automatic container deployment and management, right? So many of the manual processes involved in deploying and scaling at containerized applications. Okay, look at it. So features of Kubernetes. What are the features available in Kubernetes? Let's try to understand. Look at it. So automates various manual processes and controls server hosting and launching. Automates various manual processes. So whatever the manual activities we're performing, those we can automate by using Kubernetes, right? So control server hosting and launching. Next one, look at here. Manages containers, offer security, networking, and storage services, right? So look at here. When we talk about storage, In Kubernetes, we use the persistent volumes. In Kubernetes, we use the persistent volumes. So what is persistent volumes? This is high performance volume, right? So here in Kubernetes, we have two types of applications. Kubernetes, we have two types of applications. First one is stateful application. Second one here is stateless application. First one here is stateful application. Second one here is stateless application, right? What is stateful? What is stateless? So now we are talking about the storage only. Look at here. We are talking about Kubernetes storage. So here, stateful application, stateless application. What is stateful? What is stateless? Let's try to understand. So stateful application. So this applications normally for this applications we use the backup. For this applications we configure storage, right? So here data will be stored. Data will be stored, right? In the stateful application. So in case, yeah, in case the application is crash or anything goes wrong, data will be available for this stateful application. But stateless application, no data will be available. No data will be available. So stateful application, data will be stored on the storage, but stateless application, no data will be available, right? So what does it mean? Let's try to understand. For example, if any product launches, right? Normally the promotions, right? Promotions. For example, let us take Flipkart and Flipkart. Flipkart application configure as stateful. Flipkart application configure as stateful. So because the data should be stored in case servers are crash, application crash, anything goes wrong, right? Data should be available, right? The data should be stored. The data should be available. Understanding, right, everyone? That is stateful application. That is stateful. But stateless, what is stateless? Right? So stateless is nothing but so for the application, for the Flipkart application, backend, sometimes they add some promotions, right? Promotion applications or something they give offers, right? Temporary applications they run. Those normally we don't need to store. Data will not be available. So temporary applications and promotions, we don't require any storage, which is stateless application. Stateful is nothing but most of the applications we can configure as stateful, but promotions, temporary applications, we can configure as a stateless, right? Stateful, stateless. Yeah, look at here. So manages containers, offer security, networking, and storage services, right? Next one, look at here. It monitors and continuously checks the health of nodes and containers. So Kubernetes always monitors. Kubernetes always monitors the health of the nodes and containers, right? Next one. So automates various manual processes and controls our hosting and launching. So we can automate the manual processes. Next one. Automatic rollback for changes that go wrong. Rollback అంటే ఏంటండి? Anyone? What is rollback? Anyone having idea? What is rollback అండి?
Reverting the changes.
Reverting the change. Exactly. Correct. So for example, we deployed some applications. We deployed some applications, right? So the deployment is failed. When I perform the deployment activity, the deployment is failed. So Kubernetes, what it will do, it will roll back automatically. It will move back to previous state, right? So rollbacks are nothing but revert back to previous state. Okay? Yeah. Next one, look at here. Kubernetes mounts and adds a storage system to run applications. So backend, we can attach the storages. Backend, we can attach the persistent volumes to store the data. Fine. Yeah. So these are the important features only. Now, let's move on. Look at here. So Kubernetes versus Docker. What are the differences here? Major differences. Okay. Let's try to understand. Interview questions also. Interview questions also here. Look at here. Parameters developed by Docker INC. Docker developed by Docker INC. Kubernetes developed by Google. Kubernetes is the Google product. So Kubernetes is having commutator and Kubernetes ki commutator unnara. Everandi OpenShift is the commutator. OpenShift. OpenShift is the Red Hat product. OpenShift is the Red Hat product, right? So Google is the Kubernetes is the Google product. Google is the vendor. Next one. Year released. Docker released in 2013. Kubernetes released in 2014. Docker released in 2013. Kubernetes released in 2014. Okay. So why Kubernetes released within 1 year? So Docker is in 2013. Docker is having containers. Kubernetes also having containers. So immediately after 1 year, Kubernetes released. Why Kubernetes released immediately? Because Docker also having some drawbacks. Docker also having some drawbacks, right? So what are the drawbacks? Networking issues, cluster issues, clustering issues. Cluster. What is cluster in anyone? It's a group of servers. Cluster is nothing but group of servers, group of resources. Clear, right? You will go. Yeah. Next one. Scaling. No auto scaling in Docker. Kubernetes is having auto scaling. Automatically scale up will be happen in Kubernetes. Next one. Cluster setup. Setting up the cluster is challenging. So here in Kubernetes, setting up the cluster is simple. In Kubernetes, by using single command, we can build the cluster end. But whereas Docker, it's very difficult to configure cluster. Right? Next one. Installation. So Docker installation is very easier and very faster. Docker installation very easier and very faster. Quickly we can install. But whereas Kubernetes, bit complicated and also time consuming. Kubernetes is having different installation types. I'll show you. Okay. So Kubernetes installation is bit complicated and time consuming. Next one, load balancing. Does auto load balancing in Docker? Manually, we need to configure your load balancing settings in Kubernetes. Okay. Next one, no node support here. Node support. So Docker supports 2000 plus nodes and Docker supports 2000 plus nodes. Right? Kubernetes supports 5000 nodes. This is very important difference. Interview question also. How many nodes supported by Docker? How many nodes supported by Kubernetes? Interviewer asks you. Docker supports 2000 plus nodes. Kubernetes supports 5000 nodes. Right? And also one more difference here is, look at here. Container limit. Container limit. So Docker supports 95,000 containers. Kubernetes supports 3 lakh containers. Clear, Andy? And also, next one, slave. We can call it as worker. Docker, we can call it as worker. In Docker, Kubernetes, we can call it as nodes, right? And also companies using. So these are the companies they're using Docker and Kubernetes, Spotify, Pinterest, right? eBay, Twitter, etc. So Kubernetes, 9gag. So these are all major companies, right? These are all major companies. Currently, most of the companies they're using Kubernetes. Most of the companies they're using Kubernetes. So these two differences are very, very important, Andy. Inter ask you questions. Okay, so how many nodes supported by Docker? How many nodes supported by Kubernetes? How many containers supported by Docker? How many containers supported by Kubernetes? Clear, right? Yeah. Next one, Kubernetes architecture. Kubernetes architecture. Look at here, review. So hardware component nodes, hardware component nodes. Look at here. So node is nothing but a physical or virtual server. Node is nothing but physical or virtual or cloud server. So nodes are having configurations, CPUs, memory, storage, etc. Look at here. Next one, cluster. So cluster is nothing but a group of servers. Cluster is nothing but group of servers, right? Now look at here. Persistent volumes. Volumes are storages. That volumes we can attach to the cluster. Volumes we can attach to the cluster. Look at here. So these are the volumes. 2 TB volume, 250 GB volume, 1 TB volume. These volumes we can attach to the cluster, right? Next one, software component, container. So this is the container. This is the container. In the container, we can store whatever we required. In the container, we can store whatever we required. The files, folders, whatever we required, we can store in the container, right? Container is a standard unit of software, right? So containers, Docker containers we discussed already. Next one, look at it. Look at here, software component deployment. So here there is a new concept, Andy, which is here there is a new concept which is a pod concept. Look at it, pod. This is the pod. So pods. What is pod? Pod is a pod is nothing but group of containers. Pod is nothing but a group of containers. These are all containers. Andy. Instead of the pod, we require containers. We host the containers, right? So pod is nothing but group of containers. Look at here. A pod represents a group of one or more application containers bundled up together and are highly scalable. Understanding and everyone? Pod is nothing. This is a new concept, Andy. This is new concept. Pod concept, right? Now in Kubernetes, every pod is having IP address. Look at here. Pod is having IP address, but containers are not having any IP address. In Kubernetes, every pod is having IP, but containers are not having IP. In Docker, every container is having IP address, right? But in Kubernetes, containers are not having IP, pods are having IP. But how can we communicate without IP? ఎలా కమ్యూనికేట్ చేస్తామండి ఐపీ లేకుండా? ఫర్ ఎగ్జాంపుల్, I deployed here application which is which is a prod application, prod application deployed here, right? So if I want to access this prod application, here I deployed DB, right? Here I deployed other application. So if you want to access these applications, how can we access without IP? We use the pod IP address. Use the pod IP address to access the applications, right? Yeah. Next one, look at it. So deployment, software component deployment. So these are the pods. Blue color one is the pod. These are the containers. C1, C2, C3, C4, C5, C6. These are the containers. So one pod is having one container or multiple containers. As per the requirement, we can configure the containers inside of the pod, right? So every pod is having IP, but containers are not having any IP. So containers always communicate using port number. Containers always communicate using port number, right? So this is the ingress. Ingress is nothing but security of this cluster. Now look at here. So from here onwards, it is very, very important. Kubernetes architecture. Kubernetes architecture, right? But here, yeah. So in the architecture, we have master server, node servers available. In the Kubernetes architecture, we have master servers and also node servers. So master is having different components. And look at here. Master is having cluster store, scheduler, controller, API server. These are all components. Master is having different components. Master is having different components. Cluster store, scheduler, API server, controller. These are all components. Okay. So why we require these components? What are the importance of these components? Let's try to understand one by one. Very, very important, Andy. Interview questions also, right? So interviewer asks you about these components. Okay. Look at here. So master node. Master node is a most vital component responsible for Kubernetes architecture. It is the most vital component, right? It is the central controlling unit of Kubernetes and manages workloads and communications across the clusters, right? Master node has various components, each having its process. Look at here. These are the components. etcd or cluster store, both are same one. Okay. Let's go with one by one. Look at here. First component here is etcd. What is etcd? So etcd or cluster store, both are same. So etcd is nothing but normally, for example, in Linux we have etcd folder, right? In Linux we have slash etc folder, right? What are the importance of slash etc? Anyone? In Linux, we are using slash etc folder. What are the importance of that? Anyone?
It's like database.
Internet?
It's like database.
Will be having the config files.
Yes, yes. Very good. Yeah. So in the slash etc folder, all the configurations are available. Okay. All the configurations. Same way, here in the Kubernetes master, there is a etcd component, which is cluster store, in which all the configurations are available. Cluster configuration, node configuration, pod configuration, container configuration, everything will be available in the cluster store, which is etcd, right? So we can store all the information in the cluster store, right? Next one, second component here is controller manager or controller. What is controller? So it is responsible for most of the controllers and performs a task, right? It is a daemon which runs in a continuous loop and is responsible for collecting and sending information to API server. So controller manager is the very core component, Andy. So it will control all the components, right? Next one, scheduler. Scheduler. What is scheduler? In Kubernetes, in Linux also we have scheduler, right? In Linux also we have scheduler. Scheduler is nothing but in Linux job scheduler. In Linux job scheduler. But whereas Kubernetes scheduler is a load balancer. Will act as a load balancer, right? For example, look at here. Yeah, Kubernetes. This time. application deployment workflow in Kubernetes. Look at here. So this is we can say manifest file. This is we can say manifest file, manifestation, right? So this is we can say .yml or YAML file. So this is we can say .yml or YAML file. So in this we prepare the YAML script. While deploying the application, we can prepare the YAML file here, YAML script. This we need to submit to the API server, which is available in the Kubernetes cluster, API server, right? So which is available in the Kubernetes cluster. I explained that. So from here, the deployment flow, from here it will move to the scheduler. What is scheduler? What it will do? Scheduler will act as a load balancer. It will balance the load. So now this is a cluster. This is cluster. Inside of the cluster, we have node servers. Inside of the nodes, we have pods. These are the pods and the pods. So inside of the pods, we create containers. So one pod is having one container or multiple containers. Like this. Okay. So one pod is having one container or multiple containers. So here what will happen? Look at it. So once we submit this YAML manifestation, we'll move to the API server. From here it will move to the scheduler. So scheduler, what it will do? It will distribute the load equally on node servers which are available in the cluster. Load will be balanced equally, right? Yeah. So this is cluster. This is node. This is pod. This is container. Right? So these are the components. So normal and real-time projects, we can deploy the applications like this. So deployment workflow. So stage by stage, the code will move like this. The script will move like this. YAML scripts. Okay, fine. Now we are talking about scheduler. And look at here, scheduler. Scheduler acts as a load balancer. So whatever the applications we are deploying, so the deployment will be equally distributed to the respective node servers which are available in the cluster. Right? Next one, third one here is yeah, look at here, everyone. Scheduler, it is one of the key component of the master node associated with the distribution of workload. Okay. Next one, API server. API server. So what is API server? Which is a front-end API. Front-end. Front-end is nothing but. So once we submit the deployment, that will lead to the directly API. Once we submit the deployment, it will directly lead to the API server. Fine. So these are the important components which are available in the Kubernetes master. So interviewer asks you, what is a cluster store? What is the importance of cluster store? What is scheduler? What is the importance of scheduler? What is API server? What is the importance of API server? They will ask you. I'll share with you notes also. Okay. Next one, worker slave nodes. Let's go with the slave servers. Look at here. So nodes are having pods, which is main component, right? So a pod is a one or more containers controlled as a single application. A pod is one or more containers controlled as a single application. Okay. So look at here, pod. Next one, look at here. Docker. We know Docker. What is Docker? Docker is a container tool. Docker is a container tool, right? Next one, Kubernetes. Sorry, Kubelet. Kubelet is the component which is very, very important component. It is responsible for managing pods and their containers. It is responsible for managing pods and their containers. Okay, next one, Kuproxy. Kubernetes proxy. It is a proxy service which runs on each node and helps in making services available to the external host. Clear and everyone? So here, Kubernetes proxy, it is a proxy service which runs on each node and helps in making services available to the external host. Right? So these are the components available in the nodes. Clear and everyone? Yeah. Next one. Look at here, everyone. This is a GUI. So this is the Kubernetes GUI, graphical user interface. Right? So Kubernetes is having CLI and also GUI. This is the graphical user interface. So here you can get the clusters, workloads, services, applications, configurations, storage, whatever you require. Yeah, this is a manifest file only. If you want to deploy the application, we use the manifest file. This is the manifest file. Okay. Yeah. Next one, look at here, everyone. API version. So this is also one of the manifestation, service manifestation, right? So API version v1, kind, service, metadata, name, hello world, spec. Spec is hello world, ports, name HTTP, protocol is TCP, port number 80, target port number, which is custom port number 8080. Type load balance. So why we need to prepare like this? What is the importance of this? Practically, I'll explain it. Practically, I'll show you. Okay, while working on these deployments. Next one, look at here. This is the command which is very, very important command. kubectl apply -f deployment.yml. So if you want to deploy the application, this is the command we use. Right? So once you deploy the application, look at here. Deployment created. Deployment hello world created. Now, so once we deploy the application, you can go and check the pods. Command here is kubectl get pods. Kubectl get pods to check the pods. So currently running pods, right? Next one, kubectl get service. Kubectl get SVC or service. Clear and yeah. So companies using Kubernetes. Companies using Kubernetes. Look at here, everyone. So these are the companies. Yeah, they are using Kubernetes. Major companies only. So currently, most of the companies they are using. So these are the major companies they are using Kubernetes. Okay. Yeah, look at here. These are the major companies they are using Kubernetes. So important terminologies. Important terminologies. Look at here. Yeah, cluster is a set of missions, group of servers. Node, they are the worker missions that run containerized applications. Pod is a group of containers. Replication controllers is the used to define pod life cycles. Selector, a selector expression matches labels to filter specific resources. Labels are nothing but key value pairs, right? Next one, replication sets. They define how many replicas of each pod will be running on manage and replace pods when they die. Annotation, it is a label with a much larger capacity. So a name by which a resource is identified. Volume is a storage, right? Namespace provides additional qualification to a resource name. Service is an abstraction on top of pods, which provides a single IP address and DNS name by which the pods can be accessed. So even in terminologies, these are all important terminologies. Okay. So annotation, replication sets, volumes, namespaces, right? Replication and what is replication? Anyone? Replication is nothing but
Copy of
duplicate. Yeah, copy, right? Duplication. So replication sets, different duplication sets, right? Yeah, these are all very important terminologies. Fine. Yeah, so this is introduction of the Kubernetes. Now, what we will do, let's try to understand Kubernetes installations. Let's try to understand Kubernetes installations. So we have 7 ways to install Kubernetes. 7 ways to install and configure Kubernetes. We have 7 ways. Okay. Normally 8 ways. We have 8 ways. Another one is virtual setup. I'll show you that. Okay. We have different ways also, but these are very important. Now look at it. First one here is Kubedium. Kubedium. Second one here is Minikube. Third one here is Cops. Fourth one here is fifth one here is EKS. Sixth one here is AKS. Seventh one here is GKE. Okay. So along with this, we have one more setup, which is eighth one, Killer Coda. So which is not real setup, Pandi. This is virtual setup. Right? So these are all setups, and let's go with one by one. Let us go with one by one. So Kubedium again. What is Kubedium? So this is we can configure on any server. Configure on any server, like physical and virtual and cloud. So we can configure the setup on any servers, any bare metal servers, right? Second one here is Minikube. So this is mainly for test labs and test environments. Minikube is the test environment, right? So next one, third one here is COPS. COPS. Kubernetes on AWS. Here we require so minimum T2 medium. Okay. So Kubernetes on GCP. Yeah. So here we use the Google Cloud platform. Google Cloud. On Google Cloud, we can deploy. Right. So these are all, these four we can say, these four setups we can say IaaS and IaaS. So these four setups we can say IaaS. So infrastructure as a service. Infrastructure as a service. Right. Next one, look at here. So here we have EKS, AKS, and GKE. So these we can say EKS. What is EKS first of all? First of all, what is EKS? Let's try to understand. So EKS is a elastic Kubernetes service. Elastic Kubernetes service. So which is available in AWS? Which is available in AWS? Right. Second one here is AKS.
Azure.
Yeah. Azure Kubernetes service. Yes, correct. Which is available in Azure. Third one here is GKE, Google Kubernetes Engine, which is available in GCP, right? So these three setups we can call it as, PaaS and platform as service, right? So Killer Quad is a virtual setup and it is not real setup. This is for mainly for practice only. Okay. So in our codes, we use Killer Quad, GKE, EKS, and also I'll show you Minikube. These four setups I'll show you. Okay. Minikube, EKS, GKE, Killer Quad. So GKE is a GUI only. Graphical user interface. GKE is a GUI, graphical user interface. Right? So tomorrow we'll set up Killer Quad and we can work on some, not tomorrow, and Monday. So we'll work on some activities on Monday, deployment activities. So Monday we'll configure this Killer Quad and we'll work on some activities. So after that, we'll jump into GKE. So after that, we'll jump into EKS and also I'll show you Minikube. Right? So these are the important setups available in Kubernetes. We have other setups also. We have different setups, right? But these are all very important. Any questions, Andy, so far, anyone? Anyone having any questions? Right. So setup will take some time, Andy. Kubernetes setup will take some time. That is why. So tomorrow, not tomorrow, Monday we'll set up this, Andy. Monday we'll work on this. It will take some time to set up. Fine. Clear, right, everyone? So Docker practice చేయండి. We can do Docker practice చేయండి. So Monday onwards, you need to start working on the Kubernetes. Fine. Yeah. So we can stop here. So if you have any questions, you can reach out to me so that we'll discuss them. Fine. Yeah. Thank you all.